Hey guys, welcome to Mathletics. Today I'm going to talk about Bernoulli differential equations, which are a type of first order differential equations. So a Bernoulli equation is of the form dy over dt plus m of ty is equal to n of t times y to the power n. Now m and n are just functions of t. So if n right here is not equal to 0 or 1, we can get rid of this thing, y to the power n. So once we eliminate this, we are left with an equation which we can solve with a known process. Let's see how we can do that. We will first just get rid of this thing. So we're going to multiply our equation by 1 over y to the power n. So we get y to the negative n dy over dt plus m of t times y to the power 1 minus n is equal to n of t. Okay, now y to the power negative n and y to the power 1 minus n are something that we have not seen in solving first order differential equations. So we will introduce a new variable that will make it easier for us to deal with these. So we will call v is equal to y to the power 1 minus n, which is this thing right here. We will see in a bit that this will make our lives much easier. So if v is equal to y to the power 1 minus n, then dv over dt is equal to 1 minus n times y to the power negative n dy over dt. Now, if you don't know why I added this dy over dt, this is because of this product, dv over dy times dy over dt. Now we have to do this because we don't have v defined in terms of t. Okay, now we will substitute this fellow over here. Before we can do that, we will have to move this here. So once we do that, we have 1 over 1 minus n dv over dt is equal to y to the negative n dy over dt. Now we can substitute for this here with this. Then we will get 1 over 1 minus n dv over dt plus m of t. Now we define y to the power 1 minus n as v, which we have here. So we will write y to the power 1 minus n as v here is equal to n of t. Multiply throughout by 1 minus n, so we can get rid of this thing and have this as a coefficient of 1. Then we have dv over dt plus 1 minus n times m of t times v is equal to n of t. And there you go. Now we recognize this kind of equation. This is the first order linear equation, and now we can use integrating factors to solve this. If you guys don't know what integrating factors are, then you can check out my video on those. I just made it recently. So let's solve an example to see how this whole business really happens. Suppose we have the equation dy over dt plus ty is equal to ty squared. First thing we're going to do is we're going to divide this whole thing like we did right here by y to the power n, which in this case is y squared. So we will get y to the power negative 2 dy over dt plus ty to the negative 1 is equal to t. So now it's time to introduce our variable v, which is v is equal to y to the power negative 1. The same thing as here. That's what you do. Anything that you see over here next to m of t is what you're gonna equate your new variable as. So then dv over dt is negative y to the power minus 2 dy over dt. Now we just want this to match this. So I'm going to divide all of this by negative 1. So you get negative dv over dt is equal to y to negative 2 dy over dt. Now we can make a substitution. So we have negative dv over dt from here plus t times v. We're substituting for these with v is equal to t. Now I'll multiply everything by negative 1 so I can have the coefficient of dv over dt as 1. So that becomes dv over dt minus tv is equal to minus t. And integrating factors. So our integrating factor is e to the power negative t dt, which is e to the power negative t squared over 2. Again, if you don't know what I'm doing, check out my video on integrating factors. So the next step is e to the power negative t squared over 2, this fellow right here, times v is equal to the integral negative t times the integrating factor, which is negative t, e to the power negative t squared over 2 dt. Now to solve this, we can use a substitution. Let's say u is equal to negative t squared over 2. Then du is equal to negative t dt. So 1 over t du is equal to negative dt. Now if I substitute all of this here, I will get e to the negative t squared over 2 times v, that remains the same, is equal to the integral of e to the power u du, which is e to the power u plus c. If you don't know substitution for integration, let me know in the comments and I'll make a video on that. So if we put back in what the substitution that we made for u, we have e to the negative t squared over 2 times v is equal to e to the power negative t squared over 2 plus c. Now I'm just going to divide everything by e to the power negative t squared over 2. Then I get v is equal to 1 plus c e t squared over 2. We're pretty much done. The last step is the substitution that we made for v right here is what we're going to put it back in. So this is equal to 1 over y, which is y to the power minus 1. So you have your final answer. You have 1 over y is equal to 1 plus c e t squared over 2. You can go ahead and write this in the form y equals to something. That's just actually just this. But it's unnecessary, and this is equally correct. So I hope this made things easier for you guys and you guys understood the concept and this type of differential equations. And if you did, do subscribe to my channel, and I'll see you guys very soon.